This is our Swagger spec for our API. Swagger is used to document and describe APIs. Using the localhost 8080/doc URL, we can see all the different endpoints that the API provides. To showcase our API, I'll first create a search context. I'll be using search context create here. The search context create is an endpoint that allows you to define the PIIs you'll be looking for. The example here is an email matcher, and it's using a pattern to search. I will be doing mixed matchers though. The email matcher is just for a regular expression matcher. This will match a format with an @ sign and a .com or other website suffix. DarkShield API supports a variety of matcher types for search matchers. Besides regular expressions, we have the named entity recognition model, which is right here, which allows you to find things like names, addresses, and dates. In our workbench, there is an NER model builder, which can be used to train an NER model that can then be referenced in our API by providing a path. We also support dictionary lookup. You can provide dictionary set files that contain a list of text or PIIs that you want to look out for. And I have a little example here as a list of countries. Using the same dictionary lookup, we can also provide fuzzy matching that matches on misspellings, like misspellings in names or addresses. And let's create this here. So I'll hit try out and execute. Here's our curl post right here. To use the search context that was created to search through data, we would use search context.search endpoint next, and that would be right here. Notice the text here. This is a sample text containing an email, random@gmail.com, and we're going to be doing mixed matcher context. So this one, the text here is, hello, my name is John Doe. My email address is johndoe@gmail.com. We got a name and we got an email to look at. All right, let's hit try out. The list of annotations that has been returned includes a name and an email. It shows the location in the text that was given above. We got John Doe and johndoe@gmail.com. If we wanted to take the annotations and then mask them, we can use the mask endpoints. Shorten this. There you go. Mask context create endpoint here. And we want mixed annotations. Mask context contains several things like a list of rules that we want to apply. Here's our rules. Here we have format preserved encryption for names. This would be our encryption format preserve, AES encryption. It retains the original character length. Next, we have a hashing function for emails right here. Both rules are written in our SortCL language. SortCL is the engine we use for masking both our FieldShield and DarkShield products. All of these expressions are available in our manual. See, after supplying rules and masking context, you'll need to supply the rule matchers. Here's the rule matchers right here. Rule matchers define how an annotation is associated with masking rules. This is a way to define different masking rules for different types of annotations, so you can hash emails and encrypt names in one request. And let's try this out. Execute. Okay, it's been created. And let's do mask context.mask next. Now that we have defined a mask context, we can send requests to the mask context.mask endpoint to perform masking. The annotations list we'll use to determine which portions of text will be masked, and we can test this out here. Try out, execute, and this is the results here. Both the annotations and mask results are displayed. You'll notice that the name John Doe has been changed to WASEDK because of format preserving encryption. And then we got our email address that has been changed to this string of characters here. Got John Doe, the resulting mask, the same down here for email. We can also do the same exact process done previously in a single request called search_context.mask endpoint. Let me just set something up here for us to see. We got hello, my name is John Doe, and my email address is johndoe.com. And let try out, execute. And you see we get the same here. We got the rules applied, FPE name rule, and the email matcher. And we got John Doe changed to was EDK. As you can see, it's all the same as if we had done the 4 steps in the endpoint. The DarkShield Files API supports file-based search and masking. The DarkShield Files API supports different file types like Word documents, CSV files, PDFs, text files, JSON, Parquet, and XML. We also support different image formats like PNG and JPEG using optical character recognition, so we can parse text and mask in images. The DarkShield Files API, like the base DarkShield API, uses the same searching and masking contexts. That said, the DarkShield Files API also uses search matchers designed for specific formats like JSON and XML path filters, and I believe I have a little example here. We got a path specified here for XML, and we got a JSON path here specified. This would be the setup file that you'd use in our demos. You'll notice that I have a target bucket that I'll be searching from. It's got some CSV files, got some JSON, XML, Parquet, and I got some nested folders here with some text files in it. There you go. You'll notice that for the demo, I'm using the file search context.mask. It requires only one single request instead of 4. This is a setup file. We got our rules specified here for mask context, and we got our rule matchers defined here. And for our search context, we got a matcher for our social security numbers, a country matcher, a name matcher using the NER model recognition, and email matcher. Now to run this demo, you'll need to install the dependencies listed in the requirement text that's included with it. When you execute the program, it takes 3 arguments, the last one being optional. The first is bucket that you're going to be sending the masked files. So I'd be doing masked. And right here, let me go back. This is masked bucket. Notice it's empty right now. Now, if you specify a destination for the files that doesn't exist, it will be created. You just have to make sure that the name is unique, because if it's already taken by someone else, you'll get an error thrown back to you from Google Cloud. And this is the bucket we'll be reading from, bucket IRI. And I will not specify a folder or a path, but this is what it would look like if you wanted to. I'm actually going to be reading the entire bucket, so I'm not going to specify a particular folder path. This means it's just going to read the entire bucket and search and mask. And it's going to have a results file loaded with results JSON. And I'll hit enter. Okay, it's been search and masked, and the mask bucket that was previously empty, all right, now has some masked text in here. Let's pull some up. That was email right there, but let me get something better. All right, here's a JSON file. Yep, so the email's been masked and the name's been changed. Let's go to the original bucket and see what the original looked like. Yeah, it was originally this. See if I can pull it up right next to each other. Yes. Yep, with format preserved encryption, you notice that amount of characters is the same for name, and the email has been masked too. And let me go back. So this is mask bucket. All of the files have been masked, and that includes the nested folders here. And we have results that have been put in here, and if you look through here, you got a results JSON file here. You could either erase that one line of code in the glue code, or you can upload it to the mass blob with the other. You can upload it to a blob or somewhere else. I mean, it's really just verification that it's been masked, you know.
The API will return this as a response, but you don't have to take this. You can take just the file, the mask file.
Yes, it's being applied to. We got a CSV file. Yeah, we got JSON, XML, Parquet, text files. If you don't specify a particular folder path, you could do individual files or individual folders if you specified it as a third argument. See how I only have two arguments, the destination bucket, the bucket that's being searched. If I wanted to, I could do folder 1, folder 2, and then the file.
This would also be true. The same treatment of the plain text results in the same ciphertext everywhere, so long as the same rules are specified. So you would get these same John to Mary mappings in database columns too, or Excel sheets or whatever. It's effectively linear in scalability, is it not, guys? Devin, you did the Parquet benchmarks, right? So you know how it scales.
Yeah, it scales linearly.
Okay, so 5x volume is 5x in time it takes to mask it. It's really more about the read-write than it is about the mask itself. It's the I/O that it takes to get it to our engine and back out of it, back to your or actual I/O backplane co-location between the source, engine, and target, in as much as possible to shave the possibility of network latency.
To decrypt what's been encrypted, you have to then match it on what's been encrypted if you want to decrypt the exact same stuff. If you use like a JSON path matcher, then that can still work the same. So you can use the same matcher, encrypt and decrypt, but if you're using like set matcher, so a list of entries, and it gets encrypted to something else, now the set matcher is not going to match on what's been encrypted.
Yeah, the replace car function, if I assume it uses the same or similar syntax as what we have in Field Shield and Cell Shield with the offsets.
Yep, that's right.
I'll look up in the setup file here. For the social security number.
Perfect example. Yeah. So you're masking 1 for 3, then 5 for 2. Yeah, that's the way it works. Try before you buy type thing, where we would give you either probably a Windows or a Linux instance of backend package code, which you need to actually perform the masking and get a license. And we'll support you through the trial software installation and licensing and configuration so that the POC can succeed.